Okay, now we're back. Took a little while because I had to see my countryman Blackpink. Just a short break with coffee. Anyways, we are now going to our details, the footing detail. And for this footing detail, we have two options, whether to draw it or to copy paste. Okay, so I will make a new page, press the plus sign. It should become on page 3, so I'll move this down. And our pages tray, move it down. I'll call this footing details. Alright, the first way is to manually draw it. Okay, making the footing and then the column. You can even put it as a corner footing column. You can make it rectangle or square. And you can start even drawing the rebars, the vertical bars inside the column. So that's manual drafting, and you can also place the column ties. In cases of beams, then the beam stirrups. And you can just make it look like, okay, whatever is reflected in your structural analysis and your engineer's recommendation. So these are examples only. Maybe this can represent the bends from the vertical bars. And since this has a pattern, I can turn that off and I can even draw on top of it. So what I just did there, my shortcut for pattern fill is letter P, or remember, just turn this off. And if you want to turn that on again, you can place, something just like this. So that the builder will know visually that this is covered in concrete and the bars are here. And then you can model or you can draw your other bars afterwards. The problem with this though is that if we put a dimension, the scale might be all wrong, right? So we'll have to put a scale onto this. However, since we did it naturally freehand, we do not know the scale. And that's where method 2 comes in. Make scale drawing, choose the scale, and do everything over again. However, since our floor framing plan already has a scale, good thing we did that first, we can just copy the whole thing and leave the footing plan behind. To demonstrate, copy this first, go to that page and paste. Right now, we do not need the column grid. We do not need the grade beam tags. Good thing footing and columns tags are left behind because we grouped them separately. Now it's starting to reap what we saw. We do not need this beams as well. Let's just leave the top part. So go inside the groups and delete the others. Column group and delete those. Column tags and delete those. Footing tags and delete those. We're done with our footing plan. Furthermore, since it has a scaled information, 1:75, even our column has 1:75. Our text, however, are just groups, and we cannot put a scale to them if we just use it for labeling. But since they are groups, they have an option to still be scaled. So we can scale them also. C1, scale 1:75, and footing, scale 1:75. And let us see what happens if we select everything. So all of them have scales, and change 1:75 to 1:50. Let's see if it will be accurate. Okay, so click 1:50, and we will see the problem. Okay, so the problem here is that they are disaligned. So you can choose to manually align them again. However, all the scale changed to 1:50. So how should we go about this? I will undo. Okay, undo. So originally, our footing has a scale, our column has a scale, and our text did not have scales. What we could do is to group everything as one group. So make group. The problem with this is that since there are different scales inside, we cannot make the whole group into one specific scale. Therefore, we should remove the scales. So I'll go inside this group, right click the column and remove scale. So it's just a group right now. Right click the footing, remove scale. Okay? Now if I click on this group, there's no scale at all. It's just a group. But I know that this scale is 1:75 because I copied it from the floor framing plan. So I'll make a scale there, 1:75. If you could see, it has a scale now. And I will change 1:75 to 1:50. The whole thing becomes bigger. Okay? So whatever scale you want your detail to be, let's say 1:20, just go here and change the scale. Alignment is the same. The text did not become bigger because text should be edited in text style. We're only editing the scale, that's why we're tweaking scale drawing. Now what happens if we add dimensions? So D for dimension. If I click on this to here, I could see a dimension also for the column, which is the correct dimension. If I go to my dimension style, the reason why it's the correct dimension is because auto scale is on. What this means is that auto scale will follow the scale of the drawing if it has a scale. If I remove the scale, our dimensions do not have anything to automatically scale. Okay? In these cases where there is no scale to the groups, you can either make a scale back. This is now 1:50. And the dimensions will have a scale. Or you can override it using the dimension style, turn off auto scale, and go 1:50. This is in cases where you want 1:50 to be throughout all the paper, regardless of the drawing. Okay? So since this has a scale anyways, 1:50, I have to change this to auto scale. So currently now, this drawing is 1:50, right? And our dimension style is also 1:50, however, it's not auto scale. The problem will come when you try to rescale this. Let's say 1:75. Our dimensions still remain into 1:50. That's why instead of this being 30 centimeters, it became 20. So better enable auto scale. Just replay the video if that's a bit too confusing, because right now we really have to put dimensions here. If I remember it right, 2 pages ago, our grid is snapped to the edge, the middle, and the edge. Okay? Just for floor plan consistency, that's where I'm going to measure right now. Even if the structural engineer computed based on central weight or centrifugal weight. Okay? For this purpose, I'm only placing these dimensions in order for layout and staking. Now I see another problem. Why is it 0.20 meters when this should be 30 by 30. That's because a while ago I pressed auto scale, so it became the right scale. However, if I press dimension again, it goes back to my 1:50 setting. So what you should do before putting your dimensions, edit the settings first. This should have been auto scale. But since I drew everything already, I will just edit my dimension style to auto scale. And there's no problem at all. Right now we have a thing called schedule. So if you make a table, just drag from how many columns, let's say 3 and 3 rows, okay? If the engineer makes a recommendation and there's not much time to draw, you can have it as a schedule. Let's say this is width number 1, width number 2. This is the footing 1 and footing 2. So in meters, the engineer says, oh, width 1 of footing 1 should be 4 and width 2 should be 8 or 8, okay? So what you could do is edit this to width number 1 and width number 2. And you can delete this inner dimensions. This is the use of a schedule. It's like placing a tag, but instead of the tag labeling the drawing, it's a tag labeling the dimension. Like, please see width number 1 over here. That's a call out, but it's a schedule form. You know your calendar schedule? That's why it looks like that. So this schedule actually puts information into this legend W1 and 2. As per technical specification rule, whatever is in the schedule should override what's in the drawing. So for example, this is a square, right? 2 by 2 meters, okay? Let's call this W1 or width number 1 and width number 2. Let's say the structural engineer recommended based on soil test and his analysis that this should be 3 and this should be 2. So width number 1 should be like this and width number 2 should be like that. If you have no time to draw this, then always follow the schedule. Yeah, because as said a while ago, this shall override the drawing. However, since our drawings are already scaled, you should have no problem adjusting this just 1 meter higher. So 1 as basis and go up. So if you still need to measure it with exact dimensions, then there's no problem because they're already placed to scale. However, yes, it will take much time because if this is not final and you keep revising, then there's not much time to edit drawings. So I need a good drafting technique in order to understand the situation of the structural analysis. Okay? So we're basically done with our footing plan. Then just like a while ago's drawing, you can add the rebars if you like. You can even add your pattern if you like to show a concrete fill. Concrete fill. But of course this is not like this. It's too unconventional. So since the column has a scale, we can just copy that down here, delete the footing. leave one behind, okay? So let's ungroup. And this is our column 1. We can make the scale bigger, so 1:20. And from here we can add our bars. So line weights can be found on shape style, stroke. Let's say that's a column tie. And you want to make it, just a bit meticulous. So focus more on your select, deselect, and copy shortcuts. And you can just make something like that. Okay? So it's up to you how you want to detail this based on the structural analysis. And then you can start labeling them afterwards. Let's see our layer. So we have been drawing in dimension the whole time. Okay, can put this in layer layout. Also this one as column. Okay, tags, no problem. Tags, dimensions, column. Okay, this will be the title or text, and this will be the column plan. For the labels, of course, that's already technical specification. So here you can put like 20 millimeter diameter vertical bar, vertical, let's say corner bars. Okay. And if you want to add the arrow more, you can just extend it here, copy that style and paste it. Okay. Flip. And then you can label this as, okay, when you copy the label, this is going to move. So you have to put your mouse where the pinpoint is. Make sure the mouse turns into a cross and then you can copy it. Let's say we have middle bars. You can make this like 16 millimeter diameter vertical middle bars. Okay. So put those labels. This one will be a call out, so you can even make a style that looks like this. It's basically your discretion. Since we already have plans, we can make the sections. Remember our split and glue. You can use those techniques to make the section. Let's say this one. I want to make a section for this. So let's say I'll just copy this. I can make section for both, yeah? Okay, let's say I'll make the scale drawing inside so I don't have to rescale again. Let's say there. This will be the footing height. Okay. And then I can make this aligned up here. And then I can check what height I have to put them in. Let's say around 60. Okay. So if I want it exact, I just draw a line, 0.6 for reference, and then align it there. And then I can draw this as well as my reference for the column. Since when I drew the line and I right-clicked, auto join was off. That's why this and this are not together. So what I could do is right-click auto join lines, look for the edge, and they are joined now together. It becomes a rectangle, so fill is enabled. Copy that. Copy this. Okay, can we make them smaller? Now we have a section. Can delete the plans. Let's leave the tags behind. Okay. So this can be the same label, column and footing. You can choose to make the section cut symbol as well. No problem. Okay. And then make an invisible fill. Invisible stroke. There, just so that that part is hidden, right? And we can turn this into straight lines. Copy style, both, okay? If you still want to show the section from the intersection, then you can split, delete, or split again. This has a fill, so I'll disable that first. Cut that, delete. There. There, now you have the combined footing section. Do it here as well. Oops. Have to disable the fill because it's covering the line. Split that again. Okay, we're done. So if you see, these lines are not connected because of our split, as well as this one. That's why if we try to put a pattern here, it does not go all the way up. Okay, and we have to make this go forward again. Arrange, bring front. There, simple. And then you can just make a diagram of your rebars. Turn off fill, okay. Copy and flip. Let's Shift F. Make those little nodes. It's up to you how you design the spacing as well, since these are already scaled. So example, if you want to scale this super detailed like 0.3 or 0.2, then 3x, that's 3 times. It's just going to follow whatever you want to do. So you have to decide on how you want to approach it. This can resemble some ties. Let's say, for example, 0.15 on your first, 0.05 on your first tie. If you actually measure the dimension, it's very close to accurate because it's inside the scale. Okay, but this doesn't really need to be super duper scaled because you're going to put the designer label later on. That means how it should be spaced or the instructions. Here in Baguio specifically, we put like almost 5 centimeters and around 2 to 4, 10 centimeters. And it gradually extends like even to 150 or 15 centimeters on each intersection. So let's say, for example, this is the soil level. From here it goes up. And let's say, for example, that this is where the beam is. Okay. A good thing it's not connected, so I could scale it up. Okay, there was one rule here because of the 1990 earthquake. Aside from these column ties gradually becoming closer on each intersection, we put like 4 extra ties on the intersection itself, if possible. Because most of the buildings they found that collapsed during the earthquake were actually faulty when it came here toward the column beam intersection due to lateral movement. Okay, so that's what they said in architecture school. Anyways, the main point is that the closer the reinforcement here, the better the reaction to compression. That means load going down. And since concrete is a compressive material, while steel reacts best to tension or pulling, then we really have to take care of our intersections. Okay? So usually our other ties are like, the rest go 20-20. That's 20 centimeters or 8 inches until they reach the middle, so +1. And then you can make your pattern again, this time without the stroke. So I'll disable the stroke. And you can make your soil pattern. So just change that to soil. Look for material symbols. Earth compact fill, and we even have crushed rock. Gravel. Okay. However you want to depict your section. The reason why I'm not showing this very accurately is not only due to the time constraint, but also because we have scrapbooks. So I'm giving that for supplementary practice. Scrapbook I just prepared from long time ago. So here, you can just drag and drop, and you're done. See, it has a column length and column width. Actually, you can make this column width 1, column width 2, footing length, footing width. So that when you come to your schedule like this, instead of redrawing everything here, you can just input the size here. And as I said, if you're rushing, this overrides the instruction here or the illustration. However, all your other instructions are here, such as 16mm diameter horizontal bars spaced equally at 150mm, that's 6 inches both ways. This one is pointing here. Okay, so this is the bar he's talking about. If you want to add more presentation, since that's a shape, just add it in shape style. Okay, so that's a bar he was talking about. Actually, that's a bar I was talking about. I made this. And then you have your section detail. And then your instructions here to the right side. So you can just do that and arrange them on page, okay? So I'm going to leave this as is here so you can see what happened in our video template. Is this the beam? Yep. Okay, for beam, this is the section. We also have our slab section or floor section. So I'll leave this tag as well. You can use that. Just remember to subscribe for more updates, okay? So for our beam, you might have a hard time redrawing this all over again. So you can just copy this, put a scale to it if you want to. Or just, not to scale and then place labels all over. But don't put dimensions if there's no scale, because they might actually follow that if you don't have other instructions. Okay, so the analysis or the meaning of this is that From center to center, we follow the span of the column. In our column grid a while ago, our other columns were spanned from the edge. So this is center line, that is the materials, that is the line symbol for center line. It's just dot dash, okay? So this has nothing to do with the column grid a while ago, if we're going from center. And from the inside, we call that the clear span. So that's what we use to measure the length of our beams in order to compute these stirrups, okay? So if it's a column, you call it column ties. If it's a beam, you call it stirrups, okay? Don't call it column stirrups or beam ties. So that even without these words, we know what we're referring to. Uy, lagyan mo ng stirrups. That means look at your beam or your biga. Okay, as we said a while ago, steel is more of tension. That's why on our supports or the edge of our beams, we have reinforcements above or the top bars, and in the middle we have reinforcement in the mid span or in the bottom bars. Okay, so this illustration doesn't look exactly what it does in 3D or in real life. That's why we have to separate the lines so that it won't look like this, because it will be hard to differentiate. And then these are section symbols to say please look at the section detail for the arrangement of these rebars. Is it 16 millimeter or what? Okay. So since our load goes down here, our reaction force against gravity and weight goes upwards. These are important because the span of these will determine also how strong the support is. We do not want our beam to bend downwards or to buckle. Okay? So what other people do sometimes in real construction, they make these rebars go a little bit higher. They bend it a little higher because once pressure is there, it starts to sag. And once it starts to sag, then bye-bye building, revoke license. Okay? So, where's that part? I need that part. Unfortunately, I did not put it in the scrapbook yet, so this section will look like this. Basically, it's the section view of where the flag is facing. Like for example, it's going to look like this. See? Easy. Not that accurate, but easy. So this will be the B. That's the width. And the lowercase d for the height or the depth. Okay? And then in your schedule, you can put B equals how many centimeters and D equals how many centimeters. And then you can place here like 1, 2, 3, 4, 5. 5 pieces of 160216. That's diameter. Okay, 16 millimeter diameter rebar or top bars. Top cars. And this will be 1, 2, 3. 3 pieces. There. Okay. So that's how it will look like where at support. Because at support we have more top bars, and at the mid span we can invert this. So just select that and flip, Shift R, top to bottom. Okay. Yun. I can flip these as well. You can choose to edit and edit. But for me, I like flipping stuff. So 5 is now down here, and 3 is up there. So always have this checked by the structural engineer. Don't assume to know everything. Alright? This will be mid-span. If you put this to scale, then this can actually have its own dimension. But as I said, if there's no scale, just place a schedule tag. We'll see our floor section now. You can actually use this to label like that. You can put beam section A. Well, that's also section B. And your title could be like beam details. So this is what you put in your drawing number. You don't have to put 1, 2, 3. It's gonna take so much time. Alright, for this we have our main floor higher than our toilet and bath or terrace. So that is 5 centimeters or 0.05 meters. Depending on the use of your floor, if you're using steel deck or concrete slab, then you can change the dimensions here. Or you can make another schedule again and call this T for thickness. And then make a schedule and write down the thickness. But however, remember that this also includes the floor finish line. So always have an adjustment of 2 inches or 5 centimeters for the tile topping. And this one indicates the wall section. So it's a plastered finish with 10 millimeter horizontal bars every 3 layers of CHB. So if we try to make more drawings for that, let's say this is the concrete hollow block wall, assuming 20 centimeter height or 8 inches. Okay. What it's basically saying is that every 3 layers, so that's 1, 2, and 3, you place a 10 mm bar horizontal and vertical bars at every 1 foot or 30 centimeters. So example, you started here. Oops, where was that? Then our vertical bars will be every 30 centimeters. Well, isn't that too near each other? That depends also if you're using a load-bearing wall, or you're using it for the fence, or you're using it here for your exterior wall. Okay. Actually, these drawings are enough in order for the contractor to give instructions to the foreman. But if you want more details, such as like in Revit or our ArchiCAD for BIM, that's Building Information Modeling, you can add more details. However, if you really want the true BIM, that should come from the 3D, which is included in our premium version, Information Modeling. Okay. So these are for your discretion and analysis with the professionals. For our roofing details or truss details, we can try to copy this plan and decide to do which detail to draw afterwards. So let's try to arrange the roof detail on this blank space. Just move this down a bit. Okay. Since this is to scale 1:75, we can make a scale drawing or a callout instead using our schedules and our leader styles or labels. So let's say for this plan, I'm going to indicate that the roof is sloping downwards over to the right side. So I can make an arrow that goes down and just put sloping down 2%, or actually the height. In this case, we can draw this according to the scale of the plan. And let's say it slopes downwards over here. This is not the same as the 3D model if you check it inside the SketchUp file. But let's say because of our details, we need to have a slope, so it's not that obvious. But I remember there's a firewall here, and rainwater needs to run off here. So check your building code for the standard offset of the firewall, because the roof should not be extending over the firewall. What will be the use of the firewall in that case, right? For trusses, you can just make a simple diagram from the middle, and the middle, or you can actually divide this. So let's say, for example, I have a line. I can make a copy to the end and say I want 6 divisions, so press 6, divide, enter. From then on, you can split the lines and you can make your web members. Another way to do it is to divide this already by 6. So you can start from the middle, the midpoint, and then split. This creates another midpoint from this line. Look for the blue, and then split again. Look for the blue, and split. And you can actually make your framing here. So that really depends on what kind of detail you want to show. However, in our case, I already prepared for you a simple scrapbook with weird, kind of weird labels, because I made it curly. So I'm going to flip that from left to right. And call that our section detail. If you see here, I specified L to be the length, so you could actually put this as L, or type in the real length in your schedule, if not in the drawing. So as you can see, it slopes down as well. And you can place as well how your purlins will be placed and the rafters. However, since this is such a small roof, we decided just to stick with angle bars or web members. You also have the gutter here indicated, as well as your fascia board if you want to include that. Okay. So I cannot teach all the details of the structural because this is not engineering school, but this is to show you that you can draft it in layout as well if you don't want to do it in SketchUp. If you notice, there's no 3D viewport here. They are all layout 2D. This is the application of your volume 1. However, if you chose to put in 3D viewports here and overlay them with 2D layout, that will also be discussed in our premium version. I'll see you in the next video, lesson 3, electrical.